Hello everyone, welcome to Testronix instruments. Every material has a limit. Pull it gently and it may return to its original shape. Pull it further and it may permanently stretch. Keep increasing the force and eventually it fails. But the most useful information isn't simply the moment it breaks. It's everything that happens before that moment. A tensile test is one of the fundamental ways of studying the mechanical behavior of a material. A specimen is held firmly between two grips and pulled apart at a controlled rate. As the test progresses, the machine measures two important things: how much force is being applied and how much the specimen is extending. So, this isn't simply a braking machine. It is a way of understanding how a material responds to force. Here is one of the most important concepts in tensile testing. Breaking load and tensile strength are not the same thing. Imagine these two specimens are made from exactly the same plastic. One is narrow, the other is twice as wide. If both withstand 500 newtons, can we say they have the same strength? Not necessarily. The wider specimen has more material carrying that load. That's why engineers convert force into stress. Stress is the applied force divided by the original cross-sectional area. This allows materials of different specimen dimensions to be compared much more meaningfully. And because 1 Newton per square millimeter equals 1 megapascal, tensile strength is commonly reported in MPa. Force tells only half the story. We also need to know how much the material stretches. Suppose the original gauge length is 50 millimeters. If that section stretches by another 10 millimeters, its elongation is 20%. This tells us about the material's ductility or ability to deform before failure. Two materials might have similar tensile strength but completely different elongation. One might snap suddenly, another might stretch dramatically before it breaks. That difference can be extremely important when selecting a material for an actual product. Before testing, specimen preparation matters just as much as the machine. For many rigid plastic tensile tests, a dumbbell or a dog bone shaped specimen is used. Why this shape? Because we want failures to occur in the controlled narrow section, not beside the grips. The specimen dimensions are measured carefully because tensile stress calculations depend on its cross-sectional area. Gauge length is also defined before the test so that the elongation can be evaluated correctly. But specimen geometry isn't universal. Rigid plastic, thin films, rubber, textile and metals can require different specimen shapes, dimensions, grips, speeds and standard. For example, ASTM D638 is widely used for tensile properties of plastics, while ASTM D882 is specifically intended for thin plastic sheeting and films. So the test method must always match the material being evaluated. Tensile forces exist everywhere. Packaging films stretch during processing, wires experience pulling forces, rubber components deform during use, and plastic parts carry mechanical load. This test converts the material behavior into measurable engineering data. A tensile test is not simply about finding where a material breaks. It tells us how the material behaves before it breaks. And that is where the real engineering information lies. The specimen is properly aligned and secured between the grips. We zero the load reading, select the required test speed and begin the pull. Notice how the specimen starts extending as the tensile force increases. Look closely at this narrowing region. This phenomena is called necking. where deformation concentrates in the one area. And here we have the final failure point. The break is only the final event. The stress-strain curve tells us what happened throughout the test. What material should be pulled to its breaking point next? Tell us in the comment and subscribe for more material testing science from Testronix. For more such videos, you can visit to the website www.testronicinstruments.com today. Thank you for watching and stay connected.